Okay, so this is lesson 12 where we're going to begin doing the regression estimates. And so you'll find out here I've got two different things that we're going to need to complete as we do this one. The first is down here I've already got the template open for the actual assignment. But we also have a template for the appendices, right? So you're going to do a supplemental appendix related to the underlying linear regression assumptions, whether it's the best linear unbiased estimates or whether it's blue or not. So let's open this one up and look at the kind of things that we need to be doing. Notice we got two different formats here. The figures, we started doing the figures. We inserted this one, right? You're going to do the other three of those on the basis of those other independent variables. The multi-unit thing, and then your two independent variables. You're going to complete this. You're going to complete that with those descriptive statistics we talked about before. The regression is really about completing this. But as we're completing those tables, we also need to simultaneously be filling out the linear regression assumptions. And so we'll need to be doing some things here. So let me change the visual on this. Let me make this whole page, and we'll go through. Need to do some things like run some correlations between the independent variables, and I'll show you how to do that. We're going to have to save the residual values, and so we're going to save those, and then we're going to run descriptive statistics on them. Right? We're going to have to check and make sure that the residuals are no longer correlated with those saved residual values, so we'll need to do that for the OLS and the weighted least squares regression. To assess the homoscedasticity and heteroscedasticity, we're going to do that in terms of graphs, and so we're going to plot the residuals versus our various independent variables. Again, these are in here. They're just kind of placeholders. It's the same image, but they're just sort of placeholders. You'll delete them and insert them like we did in the previous side. Okay? And then the last thing that we'll need to do is export or create the histograms of the residuals, and we'll do that. One for the OLS regression, one for the weighted least. That's something we can do right off the regression menu. Okay, so those are the steps that we'll need to do, or those are kind of the basics informations that we'll need to do. So let's start and go through and do the regression and see where we're at. Okay, good. Okay, so we need to begin, and I think one of the easiest ways to do this is we'll just create this correlation table. And we'll show you how to run it and how to complete it. Let's minimize this. I would save both of those to your desktop because now we're at the point of inputting figures and making changes, so you need to do that. So go ahead, I saved it there and there. Let's pull up our two data files, and I'm going to do something that's actually at this point we need to do something that's kind of important because we're going to be running these descriptive statistics, and we still have those kind of 50 entries, but we have a couple of these where they don't participate, and they're not going to be in the actual regression. And so when we start running descriptives and correlations and everything else, we want to make sure that we're using the same set of variables that we are as the regression output. And so what I want to do is I want to get rid of those three extraneous cases: the Nassau County, Suffolk, and Allegheny, which is Pittsburgh. Okay, so I'm going to use my select function. If case, and I'm just going to do the same one we did before. I'm going to say missing values, invalid, and this is going to be our dependent variable. So I'm going to do that one, continue. I'm going to say, instead of filter out, I'm going to say just delete them. All right, okay, and you notice at that point what we've done is we've deleted those and we're down to our 47. So I can run descriptives, I can run correlations, I can run everything and make sure and be sure that I'm on the same 47 county unit of analysis. So that's good. Once you make a change like that, however, you need to save this as the next iteration. So let's save this as, I had this as version 4, I'm going to make it version 5 now. And again, those iterated things are very nice because you can go back to a step. Sometimes you have to retreat to a step and redo things. And so if you have iterated savings of your files, it's a good strategy. Okay. All right. our focus now is on these correlations. And so I'm going to go to Analyze, Correlate. I'm going to do Bivariate. And this brings up an option here. Let me reset that and show you what we do. There's different coefficients, but when you hear correlations, everybody means Pearson's. So the Pearson correlation coefficient, it'll give you a test as significant, and you can flag significant if you like, that's fine. We are going to go down here. The one that we are working with is that population measure that we created at 1,000 level. The other one, I believe, actually, hold on one second. I got to pause this. Okay, I had to go and check and make sure which one of these was that multi-unit housing one, and it was HSD 096212. Okay, so those are the two that you will definitely be working with. You're going to pick a couple others or go and find some more and import them, encode them yourself, etc. What I'll do is I'll just randomly pick a couple other ones, right, to show you what a table will look like. And so I'll go here, and I have no clue what these are. I'm just showing you what a four variable correlation tab looks like. All right, so we'll run that, and then you'll get the Pearson correlation coefficients. Okay. Now notice one thing. They pair them off in a table, right? So these are the same variable. You'll see the 1. So the correlation between population per square mile and population per square mile is 1. It's the same variable. And you'll see that you'll have measures on top and bottom of that, but these are all duplicates of what's down here. So when we present the table, we never do both, all the entries. We just do the diagonal one across, and we do whatever's underneath that diagonal. Okay. In this case, we include a series of variables, and those variables have we're interested in whether those variables are highly correlated. If it's above 0.7, it starts to be a problem for assessing whether there's too much correlation. The model will fail, essentially. It'll have problems allocating variance. And in this case, if we go through these kind of bottom correlations, 0.2, negative 0.03, 0.08, 0.31, 0.30, negative 0.1, we have nothing anywhere near the level of a 0.70. So we would meet this assumption. So the way it would work is we would kind of save this output file. You'll print it out at some point. You'll go to your table here, and you'll just insert those correlations, those 2-digit, correlations in this lower thing, and leave these top ones empty, if that works. So the first one's really easy. That's not hard at all. Okay, so we've got the information we need to do this correlation table. The next thing that we want to do is we want to run the regressions, because we're going to start filling out the tables. And so let's go to that. We can go back here, just click on the data file, and let's do Analyze, Regression, Linear, and it'll bring up this menu. So this isn't that hard at all. What we'll do is incidence per station. That's our dependent variable. And in this case, we had 2 independent variables that I'm going to be working with. You're going to be working with your own. So I'm going to put that population per square mile one across there, and I'm going to do that housing 096212, which is multi-unit housing. And in the case of weighted least squares, we're going to just put a weight in there. That's all we're going to do. All right. Over here, I want you to do a couple things. So we want the estimates. Don't necessarily need the confidence intervals. Durbin-Watson doesn't apply in this particular one. Model fit. We could put the descriptives in there, but we don't really need that. The collinearity diagnostics, you probably could click that, and it would run your correlations anyway. Okay, so this one's okay. We don't need anything. We just need model fit. I do want something here, however. I want the histogram of the standardized residuals. Okay, and what that's going to do is it's going to give me that one of those last plots that we're going to put into the appendix. Okay, so that's one I want there, and I want to save the standardized residuals. Oh, that's not what I want. There's 2 different things going on here. You can standardize predicted values, or you can standardize. You can save the residuals or the predicted values. And what I want is the standardized residuals. That's what we're going to do to look at the correlation for the residuals, everything else. Okay? All right. So we have everything set. We have a dependent variable, we have an independent variable. Statistics are fine. We're just going to get the estimates and the model fit. We don't need all that other stuff. You can click them and print them if you want, but don't need them. The plots, I want a histogram, and that'll work fine. On the save, I just want the standardized residuals. I'm going to continue there. Options, no. Yeah, that's stepwise. Stepwise is a no-no. It's atheoretical. It's not good. And we have everything done. We're going to run. Click and run. Okay, so we're going to get that output that we did before. This tells you something about the dependent variables, and it tells you what other variables are in there. Right? We get a adjusted square of about 0.28. That's what we were anticipating before. We get two variables. This is the beta. This is the standard error. This is the t-score that's associated with those two things. So 9 divided by 2.8 gives us a t-score of 3.3, which is highly significant, 0.002. 1.09 divided by 0.58 gives us 1.89, which is not exactly 0.05, but it's close, and it may come into play if we control for something else. Okay. These are the residual statistics, and that's important because what we'll do is it will give you, we'll need to know whether the mean is 0. That's how you refer to it at that point. So you can go, the standardized residual is got a mean of 0.0, a maximum of 72, and a minimum of 78. That's the residual. The standardized residual, which is a little bit better to use, is 0.00, 2.247, and negative 2.418. It seems fairly normal. And if we look at the normal distribution, the histogram, that doesn't look bad at all. It's got a little bit of a gap there. But generally, maybe a little kurtosis up here, but generally it looks okay. Good. All right, so we have our data. Let's think about what we need to do next. Okay, so we've run this. We've got our histograms. We've got our statistical output that we're going to complete that table with. What we need to do now is need to show you a couple things on where the residuals went. So if you go all the way out here to the right, you'll notice that ZRE-1 is the saved standardized residual. And so you can go here. If you went to the label, you'd see ZRE1. If you want to keep that, as you run regressions, it'll just keep running. It'll save ZRE2, ZRE3, ZRE4, whatever. But once you get to the final one, you might want to change that name to something like resid or whatever and keep it. But that's something that we'll use a little bit later. Okay. One final thing that we probably need to do is run the residual correlations versus the original independent variables. So let me show you how to do that. Let's go transform. Actually, analyze, correlate, bivariate. We're going to be in the same place that we were before. Right. I'm going to reset this. I'm going to go down here. I'm going to pick up my standardized residual, and that will be ZRE. Right. And then I'm going to put that with our first independent variable, and let's go find the other one, HSG, this one. And we need to run that and see if the model worked, if it ran, and if it's 0. Okay. And lo and behold, that if we look at the standardized residual and our two independent variables, the residual is 0. The model worked. It parsed all the variance associated with that and put it in the parameter. The residual is clean of any variance associated with our independent variables. Okay. From this, we have essentially the information that we need to complete most of what's going on in that table and appendix. And so we'll pick up with that in the next video. I'll just kind of walk and show you what goes where. But that'll kind of solve us now. We're getting along on the length here. Okay, good.